We are going to continue our work with our double angle identities, and we are going to solve this equation using these identities. Now, notice sometimes it won't say 2a. Well, the identity I am going to use is I'm going to use this identity. I am going to use the identity that says the sine of 2a equals 2 sine A cosine A. This is the identity that I am going to use. But you might be thinking to yourself, wait a minute, but none of those say that. I'm going to go, well, or does it? These two look a lot alike. Look, I got this sine theta, cosine theta, sine A, cosine A. What's different is this one says 2 and this one says 4. The given equation says 4, my identity says 2. So can I rewrite this using a 2? And that answer is sure I can, or I wouldn't have mentioned it. That would have just made me kind of a jerk. This can be rewritten as 2 times 2 sine theta cosine theta, and that's going to equal radical 3. So right here, you've got the 2 sine theta cosine theta, 2 sine alpha, or 2 sine A cosine A. So I can take all of this and replace it with this. Make it a little simpler to use. So the 2 right there comes right down. 2 times the sine of 2a. I'm trying to see what variable we're using. Are we using x or theta? And we're using theta. So 2 times sine of 2 theta equals radical 3. Let's go ahead and get the sine of 2 theta by itself again. So I'm going to divide both sides by 2. So sine of 2 theta equals radical 3 over 2. So where does that happen? On my unit circle. So if we take the inverse sine of radical 3 over 2, that's going to give me 2 theta. Please notice again, I'm finding 2 theta just like I did in a previous video. We're finding 2 theta. So if we look at our unit circle, where does radical 3 over 2 happen for sine? And we want it in degrees, so that happens at a reference angle of 60 degrees, which means again it's going to happen in quadrant 2 because that's also positive at another reference angle of 60 degrees. 180 minus 60 is 120. So remember though, this is twice as many rotations as we want because it's not just theta, it's 2 theta. And if x is going from 0 to 360, what that means is 2 theta is going to go from 0 to 720. It's going to do 2 rotations instead of just 1. So if that means 2 theta is going to happen at 60 degrees, 120 degrees. That's in one rotation. Now do a second rotation. So that's going to be 60 plus 60 plus 360. That's 420 because it's into my second rotation. And then 120 plus 360 is 480. That's for theta. Or, theta. I don't want 2 theta, though. I just want, that's 2 theta. 2 theta, got to pay attention to what the words I use. I just want theta. So now let's cut all these in half. So we're going to do 30 degrees, 60 degrees, 120 degrees, and 240 degrees. Now, if you don't believe me, a great tool is take all those theta values and plug them into my calculator right here and see which ones give me radical 3 as an answer. You'd need to figure out the decimal equivalent of radical 3, but that's how that works. Why don't we try the next one? So let's solve this over this interval. Well, again, I've got 2 cosine squared theta minus 2 sine squared theta. Let me gather my wits a minute. I already take 2. So this kind of, sort of, looks like one of my double angle identities. And the double angle identity I'm thinking of is the cosine of 2 theta is the same as cosine squared theta minus sine squared theta. Well, there's one problem. This doesn't say as a 2. It doesn't say cosine squared theta minus sine squared theta. It says 2 cosine squared theta minus 2 sine squared theta. So what I could do here is let's take this 2 cosine squared theta minus 2 sine squared theta and factor out a 2. So that's going to be cosine squared theta minus sine squared theta plus 1 equals 0. So now what I've got is I made my equation try to look a little more like my identity. Boom. Now those are the same. Well, what's the difference? I multiplied the blue part by 2. Now, my rules of equality say I can do that. If I multiply this side by 2, what do I have to do to the left side? Multiply it by 2. So I'm going to take this cosine squared theta minus sine squared theta. I'm going to take this out and I'm going to plug in cosine 2 theta. So we're going to say 2 times cosine 2 theta. There's this whole portion right here. Plus 1 equals 0. Now let's go ahead and get this cosine 2 theta by itself. So I'm going to subtract 1 from both sides. So 2 times cosine 2 theta equals -1. Divide both sides by 2. So the cosine of 2 theta equals -1/2. So let's go ahead and hit this up to what we have been doing. All right, so here is my unit circle. Where does cosine equal -1/2? That gives me this one. It's the third reference. It's the third angle up, but I'm on the negative side. I'm just using this. I'm using the quadrant 1 to get my reference angle, and we want to do it in degrees. So my reference angle is going to be 360 because that's where my cosine is 1/2. Because my sine is radical 3/2. So a reference angle of 60 up this way, and I would also do a reference angle down here of 60 degrees more. So this is going to be 120 degrees, and this one is going to be 240 degrees. All right, so that gives us one rotation. But remember, what we wanted to find is when is x between 0 and 360. Well, what we just did is we doubled x, remember? We doubled x, so we're not going to stop at 360. We're going to keep going all the way up to 720. So that means 2 theta is going to start off, let's look back at our reference circle. It's going to start out, it's going to go from 120 to 240 to 480, because 120 plus 360, there's another rotation, and 600. And all of these are in degrees. That means theta is going to be half of each of those. So that's going to be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Now this is not the only way I could have solved this problem, by the way. I could have used the fact that the cosine of 2 theta is also a sine squared, 1 minus 2 sine squared theta. I could have solved it using that one and just got my answers without the double angle. That would have worked as well. Alrighty, so if y'all have any questions on example 3, please let me know when we get into class. I'd love to help you with that, and we'll go over this again real quick in class, and then we'll start on our work, and I'll see you when I see you.